In this video, we're going to be going through how to solve for an oblique triangle when using the law of sines. And in this particular instance, we have a side, angle, side. Notice side, and then angle, and then side. So this is a side, angle, side case. So side, angle, side. So in order to solve for our pieces, we're first going to solve for A because it's what's across from our 25. And we're going to use the law of cosines for that. So let's remind us what the law of cosines is. And so if we're using our law of cosines and we're searching for A, we're going to go ahead and use this one right here. So we're going to plug in the values that we have to find our A squared. So we're looking for A squared, and we're going to go ahead and plug in. We have a B squared plus a C squared minus 2B times C times the cosine of our A, which is 25 degrees. So let's plug in our B, and our B value is going to be 9. So we'll plug that in, and we'll plug in our C of 12. And so now we're going to plug this into our calculator. So let's go ahead and pull up our calculator, and let's plug that in. All right, so go ahead and push enter. We're going to get 29.2375. So here we've got that A squared is going to equal 29 point, let's look at that again, 2375. And we're searching for A. So we need to finish this. So we're going to go ahead and we're going to take the square root of both sides. And that's going to tell us that A is going to be approximately, let's see, so the square root of the answer we just got. So about 5.4. So about 5.4. Let's round it out to 2 decimal spots. So 5.41. So A is going to be approximately 5.41. So let's go ahead and we'll write that in there. 5.41. So here we've got A. So next, we're going to go ahead and we're going to solve for B and for C. Now, what we might want to do is we're looking at it and we say, hey, we now have A and we have the side value of A. We can use the law of sines, and we totally could. We could most definitely use our law of sines. Because remember that our law of sines, we're just using our proportions of our sides across from the angles of this, with their signs. So we could do that. Now, if we choose to do that, we're going to end up having two possibilities. And we're going to talk about why that happens. So as we look, we now have our A, B, and C here. And we notice that A happens to be less than our B. And when our A is less than our B, then that means we're either going to have no solution available, or we're going to have two solutions available. Now we see that this is a triangle, so this tells us that we're going to have two possible triangles if we use the law of sines. So if we continue forward with our law of sines, and we find, see, the sine of B over 9 equals our sine of 25 over our 5.41. And we go ahead here and multiply both sides by 9. So that's going to give us the sine of B equals 9 times the sine of 25 divided by 5.41. And then to find B, we're going to take the inverse sine of both sides. All right, that'll cancel that out. And so we'll be able to say, okay, angle B is going to equal, and we're going to have the inverse sine of 9 times the sine of 25 divided by 5.41. And so that gives us, we're going to go ahead and we're going to plug that in. So we'll bring up our calculator and we're going to plug that in. And so we're going to plug that in, and that's going to give us about a 44.67. So 44.67. But remember that we possibly have two solutions, so we're going to have two different B's. So, or we're going to have this possible other B value. So the other measure for angle B would be that supplement. So 180 minus 44.67, which means that we also have to look at, so 180 minus 44.67. gives us 135.33. So we have to check both of those. So now that we have two angles, because remember we already had our 25 to start with, and now we have our B's, we can find angle C simply by taking 180 and subtracting the two angles that we have. So we can subtract our 25 plus our angle B of 44.67. And so again, this is for possible measures of angle C right now, possible measures of angle C. So if we plug that in, 180 minus our 25 and our 44.67, that gives us 110.33. So the measure of angle C would be approximately 110.33. And we could do that over here. Also, again, we're still looking for possible triangle. So this would be the measure of angle C that we're looking for. And so that would be 180 minus the 25 plus the 135.33. So say that the measure of angle C would be, let's go ahead and plug that in. So 180 minus 25 plus 135.33. And we get 19.67. 19.67. So remember, this is for triangle 1, and this would be for that triangle 2 of our two possible solutions. So how do we decide which one is right? Well, in order to do that, we're going to look back at our triangle at the three sides. So if we look back to our triangle, we see that we have three sides. We've got 5.41, 9, and 12. From geometry, we know that the smallest angle goes with the smallest side, the biggest angle goes with the biggest side, and the medium side goes with the medium angle. So here we see that 12 is the biggest side. So C is supposed to be the biggest angle, which only works if we have our C of 110, which means our B would be 44.67. And so those would be our final answers. So we'd be able to say that A is approximately 5.41. The measure of angle B is approximately 44.67. And the measure of angle C is approximately 110.33. And those are degrees. And this would help us to finish solving our triangle. Now, if you didn't want to have to worry about having the two different triangles, then what you can do is if you simply didn't use the law of sines and you only used the law of cosines, that's it, just the law of cosines, whether it was in the standard form or the alternative form, you wouldn't have to worry about this piece down here with our two possible solutions, because the law of cosines will give you obtuse angles, whereas the law of sines will not give you obtuse angles, which is why you have the possibility of having two different triangles. So the choice is yours. It is possible to do with the law of sines, but you do end up having to make the two triangles and then comparing them. The law of cosines, on the other hand, would be able to give you the straight answer each time. And so that's how you can find the remaining sides and angles of an oblique triangle when it is a side angle side triangle using the law of cosines and the law of sines.